Hello. For our fifth exercise, we will take a look at how we can create a loop where each iteration or each playback of the file that is being looped has a certain difference in it. So instead of looping things the same way all over again, we will play them once, then change something, play them again, then change something, play them again, and change something, play them again. I will use it with a background sound, for example, footsteps. Okay, so I found this file on Freesound. Hopefully it will load. Just some steps. And things like steps is something that you want to change once in a while, otherwise they sound too monotonous. Any city sounds or footsteps, any background like this you want to, if it's a background, if it's not an interactive sound, you want to make it change a little bit so you don't tire the ears of the user, right? So let's import. I've already downloaded the file, so I'll import it here. So sketch files, upload file. I'm going to drag that footsteps file here. Bear in mind the limit of P5 is 5 megabytes, so this one is right in the sweet spot of that. And here you go. It has been imported, so I will use my usual method of selecting all, copying, and now we can go back to our sketch. I will rename this as exercise 5 random loop, so we'll randomize the loop. So first of all, I will create a loop and I will start the loop on setup. As we know, we need to create something like a my sound, so an object of the an object container that will contain our sound, and then I will have a function preload, and I will load the sound. And I'll just paste the name I had copied before. You can use double quotes or single quotes. It's the same in JavaScript. I'll just increase this ever so slightly. I also can use a little bit more screen space. Here we go. So we're loading the sound. So then in setup, we can play it, right? We can say my sound play. And I can even set a loop of my sound. Before we play it, we can say set loop true. So let's play it just to make sure that the sound is playing well. So it's playing, it's looping. It does sound a bit repetitive, so I want it every time that it ends, that it plays again, but with a different characteristics, for example, with a different speed. Right? So how could we do this? There's another way to loop a sound. So when we go to the sound file reference, one of the methods of the sound file reference is onEnded. So onEnded allows us to do something when the sound stops playing. Okay, so it can schedule an event to be called when the sound file reaches the end. So it's another way to loop is actually to use the on-ended method to trigger a kind of a repeat function to repeat again or to do something else when it ends. If the sound doesn't loop, right, it will sound like this. So it's reaching the end. This is less than 20-second sound. So it ends here. What if I wanted to start again once it ends? So this is a loop, but we have a bit more control over that. We can create a function, for example, repeat. And here on repeat, we can simply say my sound play. So this, we will trigger the repeat function once we reach the end of the sound. And now we need to trigger it. Yeah. So we can say my sound dot on-ended replay. Sorry, repeat. Right? So it plays, and then when it ends, it repeats. It triggers the function repeat. And the function repeat, we could have called it anything else. We could call it replay, for example. The function repeat just plays it again. So this is the same as looping, but then we have a bit more control over each repetition, which is what we're gonna do next. For now, I just want to make sure it's repeating. Actually, to make sure it's repeating, we could have here, we can print to the console repeating, for example, so that we make sure this is being triggered. Of course, it will take us a few seconds to achieve that because it will only happens when the sound repeats. So let's wait a little bit and see how that evolves. Should be reaching the end. Here we go, repeating. So it reached the end of the first playback and it repeated. But it repeated exactly in the same way. What if we wanted the repetition to introduce some nuance, some kind of difference in the repetition so that our ears don't get tired? Now it repeated again. Right? So, for example, we could change the speed. So the sound theory tells us that a good way to avoid repetition of a sound or the redundant repetition of a sound is to change its speed slightly. So something like 10%, for example. I'm actually going to change it 20%. I'm going to create a variable here called let speed. This will be the speed of replay, and we can say that the speed will be a random value. So when we use the random generator in processing, we can set a maximum value or a minimum and a maximum. In this case, we know that the normal speed is 1. If I want to set a random speed of, let's say, from 10% less than 1 and then 10% more than 1, that would be 0.9, comma, meaning 2, 1.1, right? So instead of playing at the speed 1, which is the default speed, every time we play the sound, it will play at a random speed between 0.9 and 1.1. Okay, but we haven't set this to the sound itself, so we're calculating it, but we're not setting it to the sound itself. So we can just say my sound dot rate, which we know it's the method for changing the speed, is speed, which is the variable we created here. And then we could print to the console, we could cut here and print to the console the speed actually. Here we go. So now it's playing the normal speed, and when it first repeats, you will see that the speed value will be recalculated. Here we go. So now it's a little bit slower. And we will have that change of speed. So the next time it runs, it will be a different speed. We don't know, slower, faster. It depends on the random calculator. Now this is close to normal speed, so 1.0, that's close to normal speed. But every time we run, this random value, and you can change it to increase or to narrow down this amplitude. So in random, the first value, if you have a pair of values, the first will be a minimum, and the second will be a maximum. And by default, the minimum will be 0 if you only count 1. Now it's a bit faster, right? Of course, if you increase this amplitude too much, let's say between 0 and 2, that would be, so I can just put here 2. That would be too artificial, right? Because then you have very fast steps and very slow steps in a loop. That would be a bit too much. So theory tells us that 10% or around 10% can be 20% even. Now it's substantially slower. It's a bit too different from the previous one to sound natural. So I would keep it more or less to the range of values we had, which is not 0, between 0 and 2, which is what I have now, but between 0.9 and 1.1 is a good range. But you need to use your ears, and so this is way too fast, right? But you need to use your ears and check for yourselves what could be a good naturalistic change, organic change in speed. And that's it for this exercise 5.